Lesson 1.2 is about good and bad graphs. Now that we've learned about some different ways to display categorical data, we want to look at what can go wrong when graphs are made. In statistics, we often use graphs because they're a quick visual representation of data. And it's a lot easier for people to look at data and get information from it when it's in a visual form rather than just a list of numbers. Graphs can often be used to mislead others, and sometimes this is done intentionally, sometimes it's not done intentionally. And here are some things that can be done to mislead people who read graphs. Number one, the vertical axis does not start at zero. Number two, one or more of the axes has a scale that is either not labeled or is inconsistent. Number three, categories in a pie chart don't total 100%. Number four, the heights of the bars are not proportional to the amount of data that they represent. And number five, the graph uses pictures or shapes, which violates something called the area principle. And we'll look at some examples of all of these things in this video. Some of the examples are given in your notes, but not all of them are. This one is in your notes, and it says the pictograph shows the amount of Halloween candy that Shayna and Michael collected. And question A is asking, how does the graph violate the area principle? Pictographs are often used in newspapers like USA Today, where they use pictures instead of bars or pie charts because they're sort of a cute way to display data. And in this case, because the graph is about Halloween candy, they're using a picture of candy corn because it kind of fits with the theme of the graph. This is why the area principle is violated in this graph. When you look at it, your eye picks up the area of the graphed region rather than just the height. And so when you look at this, you see this triangular shape, which represents the amount of candy that Shayna collected. But visually, what you see then on the right is that the area represented by Michael's candy corn actually is 4 times as large as the area represented by Shayna's. And you can see that because we can fit 4 copies of that triangle inside Michael's candy corn. So the area principle here is violated because even though Michael had twice as much candy, as we can see by looking at the height of the candy cane, or the candy corn rather, our eye sees that the area on the graph takes up 4 times as much. Now, if we wanted to make this a better graph, we could just make a simple bar graph. So for example, we would make 1 bar for Shayna and 1 for Michael. We can keep the vertical scale the same because there's nothing wrong with that. Shayna got about 18 pieces of candy while Michael got 36. And we want to make sure that the bars are equal width so that our eye is really only looking at the height of the bars, and therefore the area is proportional to the amount of candy each kid collected. Now, there are some important features of any table, chart, or graph that you want to include whenever you are drawing a graph of your own. Number one, you want to include a title on top. And we talked in the last lesson about having a who, what, and a when you're writing your title. You want to, at least when you're making graphs by hand, use a ruler to draw nice straight lines and measure spaces. Or if you're drawing a pie chart, you would want to use a compass to draw the circle and make sure that you're measuring with a protractor to make sure that the angles in the circle are accurate. If there is an axis with numbers, you want to write labels next to it to explain what the numbers represent. It's useful to use colors or shading to create contrast between different parts of the data. You want to always include a key so people don't have to guess what any part of your graph is about or what percent it is. And then don't create a false impression by violating the area principle. Now, here are some examples that are not in your notes. This is a good example of a pictograph, and this graph is attempting to show what type of pet different people own. When you notice or look at this initially, you might notice that the data for people that own a horse extends beyond all the other data. But when you look a little more closely, you might notice that there are actually more cats than there are horses or dogs. And because the cats are smaller, it looks like fewer people have cats. So this is a good example of one where we would not want to use a pictograph. Here's a graph that violates the area principle, and this is comparing the heights of different professional athletes. So we're comparing Simone Biles, who is 4'9", to a couple of basketball players who are much, much taller. Now, because they're using people here, essentially making, again, a pictograph, it looks like the basketball players take up quite a bit more area on this graph than Simone Biles does. So again, it would be better to maybe just make a plain bar graph instead of using people as pictures. Here's another trick that's kind of common here. They're making a bar graph, but they're making it look three-dimensional. And because it's drawn so that the bars in the bar graph on the left are kind of going away from you, it makes it look like the bar that's closest to the front, which is 1995, is significantly bigger than the other bars, especially 1997. If we drew that as a regular bar graph, you would see that the bars actually are really the same height, but the 3D perspective sort of makes it a little bit misleading. Here's a graph, and this was pretty common when COVID was in the news all the time, but this is one where we have a horizontal scale that's not consistent. So if you look at the ages on these different bars, you'll notice, for example, that this first bar includes everybody from age 0 to 19. This one includes everybody from age 20 to 44. So that's an age group of 24 years. The first one is only 19 years. And then when you look at this bar, it's only including ages from 45 to 54, which is only 9 years. So the size of the groups is inconsistent, and that can cause us to kind of create a misleading graph because we might end up with more of the data in one bar than another. Here's another one that kind of uses that same trick. Notice the first bar only goes from ages 0 to 4, which is a period of 4 years. Then we have 5 to 17, which is a period of 12 years. And then the next one is 11 years, and then 9 years. And then as we move on, there's a bar that's 14 years. And so it's just not consistent. So we want to try to avoid that whenever possible. Here's one where they didn't do anything to the horizontal axis, but notice they did change the vertical axis. So this is a graph showing the S&P 500 index, which is sort of like the stock market. And notice that the vertical scale only goes from like 3006 up to 3018. So what this graph is showing, what it looks like anyway, is a very dramatic drop off right here, when really it's only dropping by about 8 points out of 3,000. So 8 points out of 3,000 isn't a very significant drop. In fact, you'll notice over to the side here, it shows that it's only going down by 0.3%. But because they showed just a very small portion of that vertical scale, it makes it look a lot more dramatic than what it really is. Here's another one that has just all sorts of problems, and this is from Fox News. Notice the vertical scale is totally missing. There's no labels on the vertical scale. And then also the time intervals that they're picking just sort of seem random. There's not a consistent scale. And then it's hard to tell whether the vertical scale is accurate because there's no labels on there. This is just a strange graph. This is showing what is your favorite season, and notice that 17% of people picked summer and winter, but those bars are a different height. Notice that spring and summer, we have summer is 17% and spring is 13%, but those appear to be about the same height. Notice the winter bar, which is 17%, is clearly more than half of the fall bar. But half of 53% is more like 21%. So this bar, there's just all kinds of things wrong with this graph here. And here's another strange graph where we're showing the number of expired nurses licenses. Again, notice lots of problems here. If you look at the vertical scale, this is 2,500, but the height of this bar is at 1,500. This bar is labeled as 1,700, but it's actually shorter than the 1,500. This one over here is labeled 2,000, even though it's pretty much right at this line, which is above 2,500, and it's shorter than the 1,500 bar. It's just lots and lots of problems with this graph again. And here's another one. This one, if you look at it, they're showing you percentages by different categories. They're showing you like what percent said approve, disapprove, and so on. But you'll notice, like, for example, in this bar, the percentages add up to more than 100%. And I think the problem with this graph is that the way they've grouped the data is a little bit strange. Like maybe what they should have done is taken all labor voters and made a graph showing approve, disapprove, don't know. That would be one graph. And then another graph would be coalition voters. Another graph would be green voters. So the way that they did this is just very strange. Please do assignment 1.2 in your homework packet.